Dongyeop, our virtual stage is yours. Take it away.
Thank you, Matt. And thank you, SAE International, for having us. It's a great pleasure to speak to you about our solutions that can help solve sealing and wear friction challenges that you may face. So coming from Omniseal Solutions, Saint-Gobain company, I'm your speaker, Dongyeop, Aerospace Technical Sales Manager. Been with the company about 11 years with a background in chemical engineering and material science. So without further ado, we'll get started. Yeah, before we dive into the technical content, I'd like to briefly introduce our organization and provide some context. So Saint-Gobain is a global materials and services group with over 350 years of history, consistently recognized among the world's top 100 most innovative companies. Our solutions are built around performance, durability, and sustainability, serving residential, non-residential, and infrastructure markets worldwide. Omniseal Solutions is a Saint-Gobain business unit dedicated to precision engineering. Our scope covers precision sealing systems, wear and friction control technologies, and advanced materials. It's developed over more than 65 years of application experience across aerospace, space, nuclear, life sciences, and industrial markets, you name it. What distinguishes our position is the combination of two complementary strengths. So first, the R&D capabilities, global infrastructure, and resources of a major industry group. And we leverage that into the technical specialization and engineering responsiveness of a focused sealing solutions business. Today, I'll be concentrating specifically on what we bring to aerospace manufacturing, the materials, the technologies, and the engineering approach that supports it. Omniseal Solutions develops precision sealing and advanced material solutions for critical applications. So our portfolio is broad, but a consistent principle runs through all of it, which is that our solutions are engineered to a specific application, a specific operating environment, and a specific set of constraints. So specialization and customization are at the core of our approach, though we are able to manufacture catalog and standard designs as well. These applications share a common characteristic, which is that they operate in extreme conditions, such as cryogenic temperatures, high-pressure systems, corrosive media, and/or high-speed dynamic interfaces. So in those environments, though not necessarily all at once, a standard sealing solution will simply not perform. The cost of a seal failure is often disproportionate to the cost of the seal itself. This is precisely the space we work in, and underpinning all of this is a strong R&D capability and a collaborative engineering approach. We engage early in the design process, working directly alongside customer engineering teams to understand requirements and develop solutions that fit into the specific application. This includes simulation services, allowing us to model and validate sealing behavior before any physical prototype is produced. The following slides will cover some of these dimensions in detail, so like materials, manufacturing capabilities and simulations, and specific aerospace applications. So here, this slide presents a map of where our sealing and material solutions are present across a commercial aircraft, as you can see. They can be found virtually everywhere. Starting with jet engines, this is our most demanding application area and where we have the deepest experience. We cover more than 60 distinct applications within the engine alone. So I won't go over every single application here, but to name a few, would be compressors, turbine stages, combustion chambers, oil sumps, main shaft assemblies, gearboxes, engine control systems, to name a few. The engine environment combines high pressure, high speed, and extreme thermal cycling. Material selection and dimensional precision are critical, as you can imagine. And across the airframe, our solutions are present in flight control actuators, gear shock struts, fuel systems, APUs, power electronics, to name a few. One dimension worth highlighting is temperature range. So applications on this aircraft span from cryogenic conditions or really cold conditions at altitude to the high temperature environments of the jet engine hot section. So this breadth reflects decades of close collaboration with aerospace customers across a wide range of programs. When a new engineering challenge comes in, there's a strong probability we have addressed something like this before. In this slide, I'd like to share how Omniseal solution delivers. So with the full capability stack from early concept through in-service support, what I'd like to convey here is that these aren't 6 isolated services, but that they're connected. So it starts with co-development. We engage from day one, collaborative problem solving, continuous design iteration, and pre-validation testing. And that early involvement shapes everything that follows. So from here, our materials and design capability is where the core engineering takes place. We develop compounds specifically matched to each application requirements. We work across a very wide size range from miniaturized precision components, say 3 millimeters in diameter, to very large diameter seals, say 6 meters in size, including complex and non-standard geometry as well. We can combine different materials within a single component. We can integrate sensing functions into polymer parts and pre-assemble subcomponents. To support the design work, simulation is built into our daily engineering activities. We evaluate wear, leakage, fatigue, and other criteria before a single part is machined. We have developed proprietary material behavior models that accurately capture the properties of our own compounds. That means that team can walk a customer through concept from concept through validation with real confidence that the solution will perform as intended. Once the design is right, we move to prototyping and MPI. Our process is structured and aligned with AS9100 and aerospace qualification requirements. We have dedicated prototyping cells at sites, including our Garden Grove in Southern California and Contiche in Belgium, with trained staff and machines allocated exclusively to prototype delivery. We offer different levels of service depending on urgency. So lead times are short by design, and process scales from first sample all the way through to full production. Behind that is our machining and molding process. So raw material to finished part, fully in-house. We cover CNC machining, compression and injection molding, stamping and direct forming. The full geometry and size range is supported from very small precision components to the large diameter seals. And finally, our involvement doesn't stop at shipment. Installation support in aerospace application is something we take seriously. Installation issues can be just as costly as design issues. We bring together engineering, application expertise, and tooling support. In some cases, we design and manufacture the full assembly, not just the seal, to eliminate installation risk entirely. Together, these capabilities allow us to take full ownership of the solution from the earliest design stage through operation and service. And one footnote that's worth mentioning, PFAS-free material option that runs across all of this, available on demand for programs where that's a requirement. So now I'd like to get into the products themselves. So starting first with our sealing solutions for aerospace systems. We have 3 core sealing solution families, each designed for a different set of operating conditions. First, starting with spring energized seals. These are our most versatile sealing solution. A PTFE or polymer jacket combined with a metal spring energizer, operating from cryogenic temperature down to minus 254 C all the way up to 365 C. Pressures from vacuum up to 15,000 PSI. The spring compensates for wear and thermal cycling, which gives you consistent sealing force across a very wide operating range. In aerospace, you'll find them in flight control actuators, fuel system valves and pumps, hydraulic systems, and environmental control interfaces. Anywhere you need reliable sealing across a wide temperature swing, with minimum friction. Metal seals take over where polymer-based solutions reach their limits. Temperatures up to around 1150 C, pressures up to around 100,000 psi, and leak rates below 10 to the minus 10 cc per second. On an aircraft, these go into the most extreme environments, as you can imagine. For example, jet engine hot section interfaces, APU systems, and thrust reverser assemblies. In space and launch applications, they're critical in propulsion systems and cryogenic fuel lines where a leak is simply not an option. The high spring back characteristic is what maintains sealing integrity across severe thermal cycling. Last but not least, rotary lip seals address a different challenge. It's our dynamic sealing solution. High surface speed rotary applications, often with limited or no lubrication. On an aircraft, you'll find them in gearboxes, accessory drive systems, landing gear actuators, hydraulic pump shafts. It offers that safety net for loss of lubrication conditions. And we have over 500 proprietary in-house formulations for the lip material, which gives us the ability to match the seal precisely to the media or fluid, the speed, and the temperature environment. Now I'd like to go to our material solutions, our polymer materials for aerospace systems. These are our friction and wear control material families. Each, again, has a distinct performance profile, and each is formulated and qualified for specific aerospace environments. Starting with rule-on fluoropolymers. So these are our original material family dating back to the 1950s, PTFE-based blends operating from minus 250 C up to 280 C with over 1,000 proprietary formulations. So low friction, high wear, abrasion resistance, broad chemical compatibility, some of the main characteristics we can find in Rulon. In aerospace, you can find these in bearing pads, wear rings, thrust washers, in flight control systems, as well as in fuel system components and hydraulic interfaces where chemical inertness is critical. Next up is melt-in thermoplastics. These are engineered for applications where dimensional precision and stability matter above all else. So typically we talk about PAI, PEI, PEEK, PPS type of materials, engineered thermoplastics. Operating range up to 280 C with international tolerance grade 6 tolerance control achievable even in high volume production. Low creep, low water absorption, excellent chemical and thermal resistance. On an aircraft, these go into close clearance moving parts in ECS systems, compressor components, and structural bearing applications where tight tolerances need to be maintained across the service life. Melt-in polyimides are where we go for the most demanding combination of heat, load, and speed. Continuous service up to 320 C, less than 0.04% dimensional variations across a wide thermal cycle. Self-lubricating grades are available. In aerospace, these are used in jet engine components, auxiliary power units, and actuation systems where high load and high surface speeds rule out most other materials. HiCom composites are our metal replacement solution for the most part. So these are carbon or glass fiber reinforced polyimide resin with mechanical strength and stiffness that competes with metal at up to 40% lower weight. Superior wear resistance in lubrication-free environments. You'll find HiCom in landing gear bushings, actuator, wear liners, and structural clamps where weight reduction is a goal without compromising load-bearing performance. Across all four families, the common thread here is that we don't just select a material grade, we formulate and qualify it for a specific application. That is what gives us the range to cover such a wide spectrum of aerospace environments. To conclude, I hope this session has provided a clear picture of what Omniseal Solutions brings to aerospace manufacturing. Deep material expertise, a broad solutions portfolio, and end-to-end engineering capabilities, all backed by the resources of Saint-Gobain and with the responsiveness of a specialized business. If anything covered today is relevant to a challenge you're currently working on, we would welcome the conversation. Further information on our portfolio and capabilities is available at omniseal-solutions.com. Um, Thank you, and I'm happy to take your questions.
Yeah, thanks. That's such a good overview. Actually, I've got one before we get to some of the audience questions. But can you give an example? What's the most innovative use of any of those products that you've seen in the last maybe the last 6 months? If that's not putting
Oh,
it.
wow. Yeah, well, yeah, thank you for the question. Yeah, that is a hard question to answer, but I think, anytime we can bring these additional values, whether it's the friction reduction, whether it's the wear life um, enhancements and combination thereof. So it's the unique customization that I was talking about earlier. So at the product level, you won't necessarily see like a star-shaped, seal or anything dramatic, but at the engineering level, we know that with enhancement of simulation, we can really pinpoint the specific and optimized design to right the first time. So I think that's the level of innovation that we continue to get better at with diverse set of materials. So really the engineering services together with validation testing service we offer to get the design right the first time is what I would say as a ongoing innovative efforts that continue to impress me.
No, no, that's great. I love that answer. All right, we've got a couple of questions about specific slides that you showed a few moments ago. So, going back to slide number 6, when you started to show the different seals, can you talk about what is the diameter? Yeah, this one. What's the diameter of those seals being shown right there?
Yeah, I think generally speaking, for the spring energized seals, we can go really small. So the miniature version of say 3 millimeters in diameter, up to say 6 meters in diameter. So that's sort of the really the manufacturing expertise that we have in terms of ranges of size that we can go. And it may differ slightly depending on which seal product, but I'm happy to engage in more detailed conversation per product line.
That's great. Yeah, if these can be used in space, my toilet broke a few days ago, so about a 5 millimeter seal. So I may be coming to you for that. All right, we've got another question about slide number 7 as well. It's asking the material identified is Meldon, which is a polyamide. Is Meldon vulnerable to the same degradation mechanisms as the other polyamides, such as Captain?
Um, I'm not sure if I'm totally understanding the question, so we may have to just engage as a follow-up. But all in all, these are proprietary polyimide material. Actually, we produce the raw material as well. And one thing I'll say is for sure the wear resistance on the high load, the high thermal oxidative stability that's been fully characterized in our Northborough R&D facility. So I think beyond that, I think any type of degradation mechanism or comparison to other types, I think we're happy to engage in benchmarking if that's something of interest to you. But yeah, these are our top of the line polyimide that fares really well against all our competition polyimides. So any more details, I'm happy to kind of share our data sheet and kind of go more in depth. Uh,
No, that's great. All right. So, Dongyeop, thank you so much for giving 20 minutes of your time today. And just as importantly, I want to give a shout out to your whole organization. Thanks to everyone at Omniseal Solutions, Saint-Gobain. Dongyeop, thank you so much. Thanks to your whole team, Clara, and the rest of your organization. Really appreciate your support today. Great information, great products. You've got a lot of exciting stuff on the horizon. So I hope you're looking forward to a good, productive rest of the year.
Thank you, everyone.